Hi, this is a 6-part tutorial series to make a complete platformer game in Gamemaker. The game we're making in the series includes momentum-based movement, wall jumping, a save and load system, and everything else you need to make your own platformer game. The goal is to help you learn about Gamemaker and what you can do in this app with relatively simple code. My name is Dr. Sky, and I'm a professor of digital media arts at the University of St. Thomas in St. Paul, Minnesota. This is part 3. In this video, you will learn how to add fade out and fade in transitions, a door system to move your character between rooms, and a camera system that follows your character along with a screen shake script you can use anywhere in your game. Let's start with the fade out and fade in system. So we're going to build a system in a script with a transition object that will appear to black out the screen whenever we want it. So first, create a new object called oFade. And in its create event, add the following. Fade out equals false. A equals 1. That's the alpha value. Target room equals no one. Fade out rate equals 0.02, which is how fast to fade out. Fade in rate equals 0.05, how fast to fade in. W equals display get GUI width. H equals display get GUI height. Add a step event. And write if fade out is true, meaning open curly bracket, close curly bracket. I always add right up front. Fade out from clear to black. See if that error goes away. There we go. If A is less than 1, open curly bracket, close curly bracket. Let's comment here. If not completely black, A plus equals fade out rate. Make more black. Else, open curly bracket, close curly bracket. A equals 1, set to 100% black. Room, go to target room. Another else statement down here. Else, open curly bracket, close curly bracket. If A is greater than 0, open curly bracket, close curly bracket. Comment, if not completely clear, A minus equals fade in rate, make more clear. Else, open bracket, curly bracket, close curly bracket, A equals 0, set to 0% black, and instance destroy. Lastly, add a draw GUI event. So go to draw and go to draw GUI. So whatever gets drawn in this event gets drawn to whatever the screen is actively showing to the player. So you don't have to draw something for an entire room. It's a great way to just like draw graphic unit, graphic user interface things like menus or like how much HP a character has. It's also great for transitions, fade in and fade out, because it just covers only the part that the player actively sees, and you don't have to draw stuff to the entire room. So let's set our parameters for this. Draw set color C black. I actually made a game where the fade in and fade out transitions was white, but that just fit the visual aesthetic of that game. Here it's going to be black. Draw set alpha A. Draw rectangle 0, 0, WH, and we want it to not be an outline, so you can put false here or 0. Want it to be a filled in rectangle. Draw set alpha 1. So here, since it's in the draw GUI event, it will start the rectangle at x0, y0 in the top left corner of whatever the player is seeing on the screen, and then it'll draw it to the width and height of whatever the player is seeing on the screen. This is going to be important because we're going to create a camera system that tracks the player's character around a much bigger room with a camera object. So that's everything for our transition object, and I just want to warn you to always make sure you write draw set alpha 1 after any draw event where you mess with the alpha value. So now we need to write two scripts, one fade in script and one fade out script, and we can use those scripts wherever in the game, whenever we want a fade in or fade out transition. So create a new script, call it fade in. Make sure the name of your script over here in the asset library matches the function name here. And write if instance does not exist, fade, two close parentheses, open curly bracket, close curly bracket. Did I misspell this? Yeah, I didn't misspell it. There. Instance create layer x, y, player layer, o, fade. And since everything is written in the o-fade object to default to fading in, meaning starting with black and then going more clear, we don't have to do anything else. The fade object will go from 100% black to clear and then destroy itself all automatically. So whenever you want to fade in, when you go to a new room, you can just throw in that script, fade in, the fade in script, and it'll work. So to test it out, let's go to the room code script and add this call for the script before anything else. So right here at the top, just write fade in and run the game. Yep, we got a little fade in at the beginning of the room now. So now if we want to fade out, we need to alter the instructions in the fade object through a script. So scripts can take parameters or arguments, which are like inputs. These parameters are stored as local variables in the script, and when the script is like this with no parameters, it just runs the script. But we can add things in this little in these parentheses here to give it parameters, like parameter 1, parameter 2, etc., and feed information into it. So with the fade in script, we don't need to do that, so we don't have that. But with a fade out script, we're going to do that. So let's create a new script and call it fade out. And up top here, we're going to write some information that's going to help guide us. So triple forward slashes at function tab or indent fade out target room, triple forward slashes at param open parentheses index close parentheses indent underscore target room. The 3 dash lines give this comment extra power. It will give Gamemaker descriptions to help us remember things later. And we're going to use the local variable underscore target room with an underscore before it to differentiate it from the target room variable already being used in the o-fade object. So let's get to writing. We need to add the parameter name target room underscore target room to the function line right here. This declares it as a local variable underscore target room. And it should turn yellow. There we go, which lets us know that Gamemaker acknowledges that it is a local variable. And then we need to create the fade object, but with it we want to change some of its variables. So let's write if instance does not exist, exists fade, open curly bracket, close curly bracket, var fade equals instance create layer X, Y, player layer, O fade. Make this a little bigger. Semicolon. With this new instance that we just created, open curly bracket, close curly bracket, let's change some of its information. Let's change A from 1 to 0. Let's change fade out from false to true. Hold on, I'm going to wait a second and let things get recognized here. Did I misspell something? Oh, I missed an E on create layer. This is not recognizing it as a local variable. Let me close that and reopen it again. Oh, because I'm missing a second close parentheses here. Open parentheses, close parentheses, close parentheses. There we go. There we go. Now things are working. This equals true. I mean, this should come up as a... Oh, yeah. So it's thinking I'm using a script here instead of the variable fade out in the object. So for that, I'm just going to change the fade out script name slightly, also with the fade in name, just to differentiate that so we don't have to change much of our code. Let's change our fade out script name, rename that to call underscore fade out. And same with fade in. Or do you know what? I don't like that solution. Let's change the variable name in ofade. That'll make it a little easier. So instead of calling this fade out, because we're having a script that's called fade out, let's call this fade underscore out. Fade underscore out, change that in the step event. There we go, that should work out. Then here, let's call this fade underscore out. Beautiful. So let me just alter my notes slightly so I don't lose my place here. Encountering bugs is just a part of the process. Just a part of the process. All right, where were we? Fade out equals true. All right, here we are. And then the last variable we need to change in our ofade object is target room, which, as you recall, is currently set to no one. We're going to set it to whatever our game puts in as this parameter, or whatever we put in this parameter called underscore target room. So target room. So we can use the script like this. When we use the script, we can write fade out, and then we can say level, R level 2 or R level 3 or whatever. And it'll fade out, give us a graphical fade out, and then transition us to that other room. So let's test it. Let's test it by going to the death script and deleting everything here. Delete it all. And just replace it with fade out global.checkpoint room. So that when our character dies, it just takes us to the checkpoint room and everything kind of reloads. So let's see if we get a fade out when our character touches an enemy or a hazard. Oh, there is an issue here. We got to debug things. It's part of the process. Oh, fade step 0. On existing room number. Room go to target room. Neofade object. Room go to target room. target room is no one with O fade. Change it to that. Is it because we don't have a checkpoint? Ah, I see. Our checkpoint room is not currently set. So let's go to r_splash to creation code. Yeah, see it says global.checkpoint room. Let's just change the default to be r level 1. There we go. That way, when we die without touching a checkpoint, it fades out. Okay, debugging is a part of the process. Debugging is a part of the process. So I'm glad that you get to see me engage with it and troubleshoot with it live in the video. So now it's working, and that is why we run the game to test it so much, because if we did a bunch of code and then there was an issue, we would have a hard time identifying where the issue was. But I was able to identify this issue and fix it in just a couple of moments because I'm running the game constantly to test it. So you'll notice when I run the game that our character can still be controlled after dying. I touch this hazard and my character can keep running. We don't want that. So let's change it a little bit so that's not what's happening. Let's make the O player explode. So in the death script, right after fade out, after the fade out script is called, add instance create layer XY player layer O explode, and then instance destroy. So remember, our player object is the one who calls for the death script. So putting instance destroy here will destroy our player object. It's going to be replaced by this explosion object. So right now, if you recall, we already have the O explosion object for our enemies when they get a weapon used against them. And now when we die, we get replaced by that same little explosion. So we're not controlling the game still after we touch something. And we get that lovely fade in and fade out. Okay, so let's make it so the player can't move during fade ins or fade outs, because it's a little weird when we're fading out and we're already able to move our character. Oh, let me do that again. See, my character starts moving before the fade in is complete. We want to make it so we can't control the player while the fade in or fade outs are happening. So let's go to O player in the step event, in the region player inputs. Open that up. We're going to add this code. If exclamation point or bang instance exists O fade. So if our O fade object is in existence, which means is something is fading in or fading out, 2n parentheses, open curly bracket, and then close curly bracket around all of these inputs. So if this fade object does not currently exist, everything works like normal. But if it does exist with an else statement, change all of these to nothing. Change it to 0. Change this to 0. Change this to 0, 0, 0. Now we're going to indent these appropriately. So this simply checks to see if the fade object exists, and if it does, then it prohibits inputs and sets all the inputs to 0. So let's see if it works. I should not be able to control my character when fading in or out. Yep. Yep. Yep, doesn't let me move until the fade out is complete. Or yeah, fade in is complete. So now let's create a system to move between rooms using this transition script, using this this sort of fade out system that we have. So let's make a sprite for our door object. We're not going to see the door object in the game, but we want to be able to see it in the room editor. So let's create a new sprite. And I'm going to call it S underscore door. And I'm going to change the canvas size to be 64 pixels wide. Sorry, 64 pixels high, but only 32 pixels wide. Edit the image, give it a nice bright color. I can even be kind of cheeky here and write door. Terrible. Set the origin to be middle. No, let's set the origin to be top left because it's going to be like in line with our squares. So let's do it top left. Top left. Now make a door object. Create object O underscore door. Set the appropriate sprite and add a create event and write target X equals 0, target Y equals 0, target room equals no one. In the step event, not create event, step event, write if place meeting X, Y, O player, close parentheses, open curly bracket, close curly bracket, fade out. Target room, but also target X and target Y. Now we're going to need to change this fade out script to include target X and target Y positions for where we want our game to place our player object in the next room. So open the fade out script and let's add these arguments. So up here where we say param, at param, let's add another triple forward slashes. At param integer indent underscore target underscore X indent target X location for player object. Make that a little bigger. Do that again. At param integer underscore target underscore Y target Y location for player object. Triple forward slashes at param integer. Actually, that's all we need. Yeah, there's no others. And in our script, before we create our fade out or fade in object, our fade object, we're going to write global dot target underscore X equals underscore target underscore X. Now, this doesn't quite exist yet. We need to declare this local variable up here. So after underscore target room, do comma underscore target underscore X, comma underscore target underscore Y. There we go. They're recognized as local variables. Global dot target Y equals underscore target Y. And then we have this regular code. So now we need to declare these global target X and global target Y variables in our creation code of our splash room. So let's go to our splash room creation code where we're declaring global variables and add global dot target X equals the same as this checkpoint. Global dot target Y equals the same as this checkpoint. Because we want to be able to go to another room without setting up a checkpoint. So let's close that. Close that. Change our room code script, open our room code script, from checkpoints to targets. So we see where it says global checkpoint X. Let's change that to global dot target X and global dot target Y. So we can move our character between rooms without creating a new checkpoint for them. But when we need this to be the checkpoint, we can put that in as a parameter when we call the script. So yeah, all of this just because when we die, we want the room code to take us to last checkpoint X and checkpoint Y. Let's close this and let's run our game, and everything should look and act exactly as it did before, but we want to just still check it to make sure we didn't mess up any of our codes. So when I die, everything works. Nope. Oh, say, good. Instance create layer, argument 2, incorrect type, undefined, expecting a number in our room code. Global.target Y, global.target X. Okay, I'm assuming that's an issue with our creation code, how we declared it. Let's just change these to these numbers. And our death script, number of see, in our death script, we didn't update the number of these arguments. So right here in our death script, we need to add here an index, then we need to add an integer and an integer, which is global dot target X, comma, global dot target Y. Let's run it now. Yep. I think it should be working. I'm noticing one thing that's a bit odd. See, I'm not reappearing where the checkpoints are. So when we're dying, it's telling us to go to global.targetX. We should, there we go. We should change this to global.checkpoint X and global.checkpoint Y. That was the issue. I'm glad that y'all get to see this. There we go. Now when I touch a checkpoint, I reappear onto that checkpoint. Very good. When I just die without a checkpoint, beautiful. Now it's working. Everything's working as before. Everything is working as before. And yeah, I saw the point in my notes where I should have added that. There we go. All right, now we can implement our door system. And before we do that, I just want to verify that I just got to think about this in our death script, if this is correct, if it should be checkpoint or target. This is right. Yes. Yes, that's right. Okay. All right, so now we can make our door system. Right click on our level 1 and find duplicate and click duplicate. So this copies the room, and we're going to name this second room R_level2. That's just a fast way to make rooms. So let's go through some things and change some things in level 2 so that we know it's a different room. So I'm going to go to, well, I'm going to just delete everything that's bad for one. And the checkpoints, let's delete those two. Under this player layer where we have all these blocks, let's remove that and change where the blocks are. Let's have the blocks like here and here. actually. There we go. So we know that this is level 2. I'm going to add a checkpoint also and something bad so we can test issues if we need to. All right, we've done that. And in the let's see. Yep. All right. I have the room editor for level 2 open. Let's also open up level 1. Move these tabs a little bit. So we have the level 1 room editor and the level 2 editor side by side. So we're going to be jumping between these a little bit to place our doors. So in our level 1, under the player layer, let's add a door in a place that makes sense. Let's just add the door. Let's move these blocks out here and move the door right there. Also, in our door object, where it says visible, just uncheck that so we know that it'll become invisible when we go to the room, when we run the game. So this makes sense. And now we're going to find a place. We're going to do the same here. Let's place the door somewhere where it makes sense. Layer. Move that here and here. Let's add a door right here. Yeah, that makes sense. Okay. So where we want our character to appear in level 2, I'm going to hover my mouse and then go over here. It gives you the coordinates. I'm going to try to find some coordinates that will look good. Let's say 587, 450. 587, 450. So right here in level 1, double click this instance and go to its creation code and write target underscore x equals something, target underscore y equals something, and target underscore room equals r underscore level 2. Now let's go back and try to find those coordinates again. Let's see. Let's say 590,448. 590,448. That's good. 590,448. So this door in level 1 will take us to level 2 and place our character right here where my mouse is. But before we run the game to see if it works, let's walk through what's happening step by step. The player will touch the door object. That instance of the door object has a specific target room set and specific target X and Y variables set that will take us using the fade out script to this room and create a character right there. And in the room code script, which is currently placed in the creation code of level 2 already, it will create our player wherever the target needs to be, wherever we set the target to be. Let's test it now and see if it works, see if we encounter any bugs, which would be totally fine if we did. So I need to get up there. Okay, let's do it. It worked. It worked. Let's do it again. And I'm going to touch this checkpoint here. Oh yeah, I need to create a door back. I need to give it the parameters for the door back. Here we go. So this door, we need to give it some parameters. So let's open that creation code. Target X equals target Y equals target room equals R underscore level 1. And let's create the player object at 46,193. 46,193. Close that. Run the game. Oh, get up there. Takes us here. And if I touch the bad object here, it takes us back to the first level with the checkpoint working just fine. What happens if I touch this checkpoint and die here? Creates me there. And if I go back and touch a baddie, takes me back to level 2. So now we have a checkpoint system and our door system is working. And if you don't like where your player object's being created, like I notice with level 2, I see my character sprite dropping a little bit, which means I set the coordinates too high in the room. One easy way to mitigate that is you can find the exact coordinates of where you'd want your player simply by dragging in your player object, zooming in, turning off the grid, placing the character flush with the floor where you want them to be, like right here, double clicking them and finding their X and Y position right here. And then after you've written those down, be sure to delete your player object because our checkpoint system only works as if we don't currently have a player already created in the room. All right, so that is all tested. Let's now make a camera system because, you know, it's all fine and good that our room is this small, but we can have levels that are much bigger and then have a camera follow the character around in those rooms. So the first thing we want to do, I'll close the room editor for level 2, and in level 1, right here, we can do this a little more accessible. Under room properties, let's make the room significantly bigger. So I'm going to make it 1,120 pixels wide and 800 pixels high. This works well with our size of blocks, which, as you recall, are what are they? 32 by 32 pixels high and wide? Can't remember. How big is our block? Yeah, 32 pixels wide, 32 pixels high. So 1,120 and 800 are could all be broken down into increments of 32, which works well for our room size. So now, sort of zoom out and see our room is much bigger now. And we need to add blocks here, make the room significantly bigger. So let's select the player layer and let me delete some of these blocks. Well, first I'm going to remove this baddie right here. And I'm going to remove these baddies too. And make it so the character, select the player layer, have the block. The player has to fall down here. Let's do that again. Can I make the grid 32 by 32? Yes. Make it a little easier. And then do this. Do this. Do this. And then do this. There we go. Let's make it so we have to jump up. Can our character jump that high? We'll find out, huh? Let's just see if this is even going to work. Then how about here, we just do another wall jumping section. Go down. Go back up, then go over. Beautiful. Yeah, I think that's it. So we made the room bigger. Now we also need to make the room for level 2 slightly bigger, but not that much because with the screen shake effect, we need our rooms to be just like one block size wider and taller. so our screen shake doesn't take us out of the room. So under width, let's change it to 672. And for height, let's change it to 544. And this makes it exactly one block width tall, one block width wider, one block height taller. And let's just, under player layer, just make that the case. And this. And let's move the door over here. And let's move this transition. 590 would be a little further, so let's do 606. I think that should be about right. 606. I'm like right here. Let's do 622. Because I moved that door, I needed to change where the target location would be for the player character. All right. And I've altered the door objects as needed in both rooms. I think level 1, that's not going anywhere, so I don't have to change that at all. All right, so now let's set up a camera system in R level 1 and in R level 2. In the properties, we need to make some changes. So let's start with R level 1. Under properties, go to viewports and cameras and expand that and check enable viewports and make open viewport 0 and click visible. And set the camera properties and the viewport properties with the width and height exactly the same. So make sure that those are the exact same size as you have your splash room already set, which, as you recall, is 640 by 512. Let's do the same here. 640 by 512. Now we need to do all this in level 2 as well. So viewports and cameras, check enable viewports. Under viewport 0, check visible, and change the width to be 640, height 512, 640, 512. Now, if you're not creating a camera object, you can just check this to have the game follow your player object. There's a little object following things. If you want a really simple camera system, you can do that. You mess with other things like borders or buffers and the scrolling speed and all that. But we want more control in our game, so that's why we're going to code our own camera object. Let's close out of those levels now, close out of that. Create a new object and call it O_camera. In the OCamera create event, write triple slashes at description setup camera. Cam equals view camera bracket 0 bracket. So that's that viewport 0 that we enabled. Cam follow speed equals 6. Lower is faster. Follow set to O player. This way we can make the game camera follow other objects if we want. Like if we have a tutorial sign pop up, we can make the camera jump over to the tutorial sign if we'd like. But for now, we're just going to have it follow wherever the player goes. View W half equals camera. Get view width of cam multiplied by 0.5. And then view H half equals camera, get view height of cam times 0.05. X2 equals X. Y2 equals Y. And this is all code to just allow for some following speed. Essentially, we can set where we want our camera to be moving towards at any given point. And in the OCamera step event, write a comment, update destination. If instance exists, our object that we're following, close parentheses, open curly brackets, close curly brackets, and let's add a comment here. Always commenting on our code. If there is an object assigned to follow, x2 equals follow.x, set x2 to be that object's x position, y2 equals follow.y, set y2 to be that object's y position. So our follow object is essentially going to be our player, so oPlayer. So if our oPlayer object exists, which is important because there's moments in the game when our player object doesn't exist, like during the death event, our player object is replaced by an explosion. But if our follow object exists, set our destination for our camera to be that object's X position and Y position, which is our player object's X position, our player object's Y position. Next, comment update object position X plus equals X2 minus X divided by cam follow speed. Move slower the closer it gets to the follow object. Same thing here, Y plus equals Y2 minus Y divided by cam follow speed. Moves slower the closer it gets to the follow object. New comment, keeps the camera from leaving room boundaries. X equals clamp. X view W half, comma, room underscore width minus view W half. Y equals clamp. Y view H half, comma, room height minus view H half. Lastly, comment update camera view, camera set view position POS, cam X minus view W half, comma, Y minus view H half. Ooh, that was a lot of typing, but hopefully you got through it. Now, we don't have our camera object added to the room yet. We're to our room code. After we create our player, we're going to add if bang instance exists, or it's asking if the following instance does not exist. OCamera, close parentheses, open bracket, close curly bracket, instance create layer, global dot target X, global dot target Y, player layer, O camera. Essentially just creates a camera object right after it creates our player object. All right, let's see what bugs we've created. Ah! Okay. Ah, there's a bug. I knew there'd be one. It is following our player object incorrectly, not as intended at least. So I'm pretty certain it has nothing to do with our room code here. It's probably with our camera object. So let's open our camera object code and let me look through my notes and find out where I made a mistake. And it's probably down here. So let me just verify. Camera set view position, cam x minus view w half, y minus view h half. That is correct. Up here, x comma view w half, room width minus view w half, y clamp, y view h half, comma room height minus view h half. That's correct. That's correct. That's correct. Create event. Follow our object player. I'm sure this is terribly interesting. View width, view height, cam times 0. Oh, there's the issue. See that? I accidentally wrote an extra 0 there when it just needed to be half. Instead of 5%, we wanted 50% of whatever this is. And that, I'm convinced, will be our solution. There we go. Our camera object has this nice sort of following thing here. I need to alter the room a little bit just so we can get up to where we need to be. Let's try that. It's following, following, following. It doesn't leave our room boundaries. Which is good. And that's good too. All right. Everything is working. Beautiful. All right, now let's add a screen shake effect to use with a camera. And adding a screen shake is really easy with the way we set up our camera object. So in the OCamera create event, add the following comment screen shake, shake underscore length equals 0, shake underscore magnitude equals 0, shake underscore remain equals 0, buff equals 16, which is the buffer that we give so we don't leave the boundaries of the room and still allow for our camera to shake up and down and left and right while staying within the room. In the OCamera step event, update the clamps here to include that buffer variable. And so where it says view w half, just add plus buff, view h half, right, plus buff. And over here where it says view w half, write minus buff. And over here, view h half minus buff. And again, in the step event, add a new section and place it right before the update camera view section, right after the clamps. And we are going to write, let me expand this a little, screen shake x plus equals random range minus shake remain, comma, shake remain, y plus equals random range minus shake remain, comma, shake remain. Now, as you call this is a step event, so this runs every 60 frames per second. So this random range is going to be updating 60 times a second. It'll be nice and jittery and shaky. And then write shake underscore remain equals, let's give it a max. So, oh, actually this will make it reduce. So whatever is bigger, max 0, shake remain minus, open parentheses, 1 divided by shake length, close parentheses, times shake magnitude, close parentheses, semicolon. Oh, and I miswrote, didn't write that correctly. There we go. Now this may look complicated, but basically it's just making it the intensity of the shake start big and then gradually reduce until it gets to 0 again. And then we're going to close this and create a new script. Create script and call it screen shake. And we will write some things up here. Let's make this a little bigger. / at desk indent screen shake open parentheses magnitude comma frames / at param indent magnitude. Oh, let's add, sorry, curly brackets. Magnitude, close curly brackets, magnitude sets the strength of the shake radius in pixels. And then another one at param curly bracket frames curly bracket frames sets the length of the shake in frames 60 equals 1 second at 60 FPS. And before we start writing this script, I just recalled that for our fade in and fade out, for our fade out script, I used parentheses here when they are supposed to be curly brackets. So I'm going to quickly fix that, and that will actually make it so this description system works. You'll see if you open up the death script where we use fade out, and we have the fade out script. If you selected it now underneath here in Gamemaker, it shows you what things you're inputting so you can keep track of these functions appropriately. It's a cool little system baked into Gamemaker. It's kind of cool. So let's close that. Back up here to our screen shake. Let's not lose the thread here. With camera, open curly bracket, close curly bracket. If Oh, yeah, sorry. I need to declare some local variables. So up here where it says function screen shake, in these parentheses, write underscore magnitude, comma, underscore frames. Now you're probably wondering why I'm adding a little underscore here. That's just a naming convention for local variables or temporary variables. You can add an underscore before them just so you can keep track which are instance variables, which are local variables that are only temporarily used, etc. Now I haven't done that too much in this project, but for functions, I definitely want to keep track of the local variables by adding an underscore in front of them. And now with camera, if underscore magnitude is greater than shake remain, which is a variable in our camera object, open curly bracket, close curly bracket, shake underscore magnitude equals underscore magnitude. Shake remain equals underscore magnitude. Oh, there we go. And then shake length equals underscore frames. Close that, close that. Beautiful. So to test it, let's add a screen shake to the death script. So let's open the death script here and add right at the top. Let's add screen shake, open parentheses. And as soon as we do that, you see down here the things we need to add. We need to add magnitude and frames. So let's set a magnitude of 5 pixels. So it's going to shake 5 pixels around, comma, and then a length of 30 frames or a half a second. So magnitude of 5 pixels, comma, length of 30 frames. There we go. Screen shake. Now, if we touch a baddie, the screen should shake. Unfortunately, I didn't place a baddie really soon, really early in the level. So let's add a hazard really quick, really early, right here, so we can test it. Yep, we get a little half-second shake. And you'll notice now also, close this, with the boundaries of the room, our camera is now stopping 16 pixels into the block object on all sides, at the bottom and on the right, stopping 16 pixels. And that's important because for our camera shake, if we set the magnitude to be something massive, we can set it to be like 16 pixels. I'll change this to so it lasts a full 60 frames. We can let it shake 16 pixels around, which is massive like that, and it still won't leave the room. Now you can set the magnitude to be higher than that, but it will stay clamped within the boundaries of the room. It will shake in every direction that big, except when it would want to leave the room. So it never ever leaves the boundaries of the room. Change this back to 5 and back to 30. Another good place to use it is when setting a new checkpoint to really emphasize the fact that we have reached a checkpoint. So in our O checkpoint object, in the step event, under where the global variables get set, add screen shake 520, so last 20 frames. Let's add it so when we're falling down and hitting the ground, if we're falling a long distance and reach our sort of terminal velocity and we hit the ground, there'll be a screen shake to emphasize that falling collision. So in our player object, in the, I believe, our collision section, yes. In vertical collision, right before we set the VSP to equal 0, you can write if VSP =, max VSP, meaning we've reached our max terminal velocity. Screen shake, let's say 7 pixels magnitude for 20 frames. Let's close that. And another place we can add it is during our attack. So sorry, I shouldn't have closed that. So let's close that and open up the attack region. And in the key attack if statement, add the line screen shake, say 4 pixels for 10 frames. And so let's test it out. So we'll be testing it at a checkpoint when falling and using a weapon. So let's use the weapon. Yeah, when I use the weapon, I get a little screen shake. And when we touch a checkpoint, we got a little screen shake. And when I fall down, I got a big screen shake. When we die, we do a screen shake. So now you can call that script whenever you want to add a screen shake, say when fighting an enemy, if you want to make it do that, or when a character is firing bullets, like every time a bullet gets fired, you can have the screen shake a little bit. It's just a really good way to sort of emphasize what's happening in the game. For instance, in the game Celeste, where you can do, it's a platform game where you can do air dashes. Every time you do an air dash with your character, there's a screen shake to really emphasize the boom of the moment. Yep, and that's it. Yeah. Now our next video, we're going to talk about auto tiling system to improve the graphics of the game and adding sounds to our game and tutorial signs. So I will see you then.